Hi there, this is Dr. Nick with the ECG Academy, and this will be the last video that we do talking about sinus node dysfunction. We've gone through the list here of different electrocardiographic manifestations of sinus node dysfunction, and we've covered pretty much everything except this last one called SA exit block or sinoatrial exit block or sinus nodal exit block. Let me explain to you what that is. Now here we have those action potentials of the sinus nodal cells. So imagine those cells are basically firing at a regular rate, right? Which is what sinus nodal cells generally tend to do. Well, one manifestation of sick sinus syndrome is problems with this diastolic depolarization. The pacemaker currents are not what they should be, and what happens is the cell takes a much longer time to fire, and what you have is a heart rate that's much slower. Well, this would be considered a disorder of impulse generation because the signals are being generated too slowly. And that's one of the mechanisms of arrhythmia that we talk about in the advanced chapter on mechanisms. So if the sinus nodal cells are firing too slowly, that will give you sinus bradycardia. But there's another situation that can cause bradycardia and sudden pauses. So here's my animation of the cardiac conduction system. And remember I talked about how the sinus node has these little extensions into the surrounding atrial myocardium. These extensions basically connect the sinus node with the surrounding atrial myocardium. These are little tracts, if you will, that extend into the myocardium. And these tracts behave kind of like sinus nodal cells in that they can fail to fire, and they may not generate enough electrical energy to penetrate the surrounding atrial muscle and initiate a depolarization through the atrium. So what does that mean? It means that the sinus node can fire, but the signal never gets to the atrium. And what happens is the P wave that should be there isn't. In other words, there's a block that occurs as the signal tries to exit the sinus node. And that's why we call it SA exit block. So here's our natural conduction system. And if I show you an animation that I did for SA exit block, you can see there's a sinus beat, there's a sinus beat, and then look, right there, the sinus node fired, but the signal never got to the atrium. So every third beat here, what I've shown you is what happens in sinoatrial exit block is that the sinus node gives off a signal, but it never penetrates into the atrium. Now, what does that look like on an electrocardiogram? Well, what you'll generally see is a sinus pause. Right? There is usually a marked sinus arrhythmia. Here, if you examine this electrocardiogram, you'll see that looking at the forest, there's a tremendous variation in the heart rate. You've got very slow heart rates on this side, then it seems to regulate itself, and then you have a pause here. If you look at the P waves, you can see they're upright in 1 and AVF, and that's fine. So they are sinus P waves. Here you've got very slow beats on the left-hand side, rates in the 30s basically, and then it looks like the sinus nodal rate picks up a bit, and here you have 300, 150, 100, 75, 60, maybe about 58 beats per minute. So you have this regular rhythm, 58 beats per minute, looks like a perfectly normal sinus rhythm, and then suddenly you have this pause. Now this is the important part. If you take a pair of calipers, and you can move these around here, right? Okay, let's just sort of like take the P waves and measure the P wave intervals. Remember, try to do the beginning of the P wave because sometimes the top part may be arbitrary. So you have a pretty regular rhythm that's going on here. And as I said, if you pick up the calipers and put it on a heavy line, you can count off a little bit less than 60 beats per minute. But the important part is when you put your caliper on this P wave here and you look to see what happened, there is no P wave in this segment of the ECG. It's gone. A P wave did not get generated. But the cool part is that if you make a mark over here and then pick up your calipers and bring it on over, you'll see that the next P wave pretty much occurs right on time. So even though there was no P wave here, the next P wave occurs on time. So what that tells you is that the sinus node did indeed fire right at this location, but the signal never got out to the atrium, so the P wave is missing. But then the next time the sinus node fires, that signal gets out to the atrial myocardium, and you do have a P wave that occurs on time. So this is an indication that you have SA exit block going on. There's another way of looking for this, And that's if you take your caliper and you measure out 2 P waves. So let me resize this thing. Okay, we'll measure out 2 P waves here. So spread your calipers apart and measure out 2 P waves. And then it's very useful to see first are the P's regular? Yeah, they are pretty regular in this location. You can see that this interval is the same as the one that I measured. And then when you put your calipers on, you can see, yes, indeed, there's nothing there. But when you put your caliper on this P wave, look at that. That double P wave interval maps out precisely. Now, this doesn't always hold because there's actually more than one type of sinoatrial exit block. But this is pretty recognizable on a lot of cardiograms in patients with sinus node dysfunction. And you can especially diagnose this when you see marked sinus arrhythmia. That's a clue. When you see sudden dramatic changes in heart rate, most people will consider sinoatrial exit block as the cause. Now, this is known as a disorder of impulse conduction, because here the sinus node may be firing perfectly fine, but the signal is not being conducted out to the atrial myocardium. And that's why you get these pauses because of failure of conduction. As I said, there's a whole section of videos on arrhythmia mechanisms, and you can watch those if you've subscribed to the advanced course. It just gives you a better physiologic understanding of what's going on inside the heart so that you can understand these arrhythmias better and be better equipped to make the proper diagnosis. After all, I want to make you an ECG expert, and that's why you're watching these videos. And so that's my discussion of sinoatrial exit block. I thank you for watching. This is Dr. Nick from the ECG Academy.